In this video, we want to solve for x given x raised to power 6 is equal to 5 raised to power 6. We have x raised to power 6 is equal to 5 raised to power 6. First of all, let us transfer everything to the left-hand side so that we have x raised to power 6 minus 5 raised to power 6 is equal to 0. Then we see x raised to power 6 can also be written as x raised to power 3 times 2. Also, 5 raised to power 6 can also be written as 5 raised to power 3 times 2, then is equal to 0. By law of indices, m raised to power a times b can be written as m raised to power a raised to power b, and it can also be written as m raised to power b raised to power a. Therefore, I'm going to write this as x raised to power 3 raised to power 2 minus 5 raised to power 3 raised to power 2 is equal to 0. If we let x raised to power 3 be a variable, say p, and we say let 5 raised to power 3 be represented by q, then we'll see p raised to power 2 minus q raised to power 2 is equal to 0. The reason I've made this substitution is so that we can clearly see the difference of two squares, and by identity this can be factorized as p minus q times p plus q is equal to 0. Which then implies that either p minus q is equal to 0 or p plus q is equal to 0. This would then imply that, p was x raised to power 3. So if we put those back into the substitution, we get x raised to power 3 minus 5 raised to power 3 is equal to 0. Or we say x raised to power 3 plus 5 raised to power 3 is equal to 0. So we have two different cases. One is negative, one is positive. Cubes are both involved. I'll call this case 1, and I'll call this case 2. Now for case 1, we have x raised to power 3 minus 5 raised to power 3 is equal to 0. By identity, given a raised to power 3 minus b raised to power 3, you can factorize this as a minus b times a squared plus ab plus b squared. So we are going to have x raised to power 3 minus 5 raised to power 3 is equal to x minus 5 into x squared plus 5x then plus 5 squared is equal to 0. Let us tidy this up. We have x minus 5, x squared plus 5x plus 25 is equal to 0. So just like we did earlier, this also implies that either x minus 5 is equal to 0 or x squared plus 5x plus 25 is equal to 0. From the first equation, we get x is equal to 5. Let's call this x1. This is the first real solution for this problem. So we're going to go ahead and solve this quadratic equation to get two more solutions. I'll compare this equation to the general quadratic equation, which is ax squared plus bx plus c is equal to 0, so that we can clearly get the coefficients. A is 1 in this case, b is 5, and c is 25. Now, using the general quadratic formula, x can be found using minus b plus or minus the square root of b squared minus 4ac all over 2a. So this would then imply that x is equal to minus b. B is 5, so minus 5 plus or minus square root of b is 5, 5 squared minus 4 times 1 times 25 then divided by 2a. A is 1, so that's 2 times 1. So we get x is equal to negative 5 plus or minus the square root of 5 squared here is 25 minus 4. 4 times 1 is 4, then 25 divided by 2 times 1 is 2. Therefore, x is equal to negative 5 plus or minus the square root of 25 here, 25 here. So I'm going to factorize 25 into 1 minus 4, then divided by 2. We have x is equal to minus 5 plus or minus, this is square root of 25 times 1 minus 4 is minus 3. So square root of all of that, then divided by 2. We have x is equal to negative 5 plus or minus. I can separate this product to give us square root of 25, then times square root of negative 3 divided by 2. So we have x is equal to minus 5 plus or minus square root of 25 is 5. Then square root of negative 3i is going to be square root of 3, then I, all divided by 2. Let us separate this division. This will then give us x is equal to negative 5 over 2 plus or minus 5 root 3 I over 2. Now we need to separate this plus or minus sign to give us two separate values for x. So we say x, this time I'll say x2. That will be 5 over 2, the positive, then 5 root 3 I over 2, and then x3 is now going to be 5 over 2 minus 5 root 3 I over 2. Giving us three values already. Let us now go back to case 2. For case 2, we have x raised to power 3 plus 5 raised to power 3 is equals to 0. By identity, a raised to power 3 plus b raised to power 3 is going to give us a plus b into a squared minus ab plus b squared when factorized. So x raised to power 3 plus 5 raised to power 3 is going to give us x plus 5 into x squared minus 5x then plus 5 squared. And this is equal to 0. So we have x plus 5 into x squared minus 5x plus 25 is equal to 0. This will mean that x plus 5 is equal to 0, or x squared minus 5x plus 25 is equal to 0. From here, we get x is equal to negative 5. I'll call that x4, which is also a real solution. And then we proceed again to solve this second quadratic equation. Here, our a is going to be 1, our b is negative 5, and then c is 25. Therefore, x is going to be minus b, which is now minus 5, then plus or minus the square root of b squared, which is minus 5 squared, then minus 4 times a, which is 1, times c, which is 25, square root of all of that, all divided by 2a, which is 2 times 1. Therefore, x becomes minus times minus here is plus, so we have 5 plus or minus the square root of minus 5 squared will give us 25, then minus 4 times 1 times 25, so we have 4 times 25, then divided by 2 times 1 is 2. This will imply that x is equal to 5 plus or minus, again we factorize 25 into 1 minus 4, then divided by 2. So we have x is equal to 5 plus or minus square root of 25 times negative 3 divided by 2. Then x is equal to 5 plus or minus the square root of 25 times the square root of negative 3, then divided by 2. X is equal to 5 plus or minus square root of 25 is 5. Then square root of negative 3 will give us 3 root 3i, then divided by 2. We're going to separate this division like we did earlier. So x is equals to 5 over 2 plus or minus 5 root 3 I over 2. Then we'll go ahead and separate the signs as well. Now we're going to have x5, which is the fifth value. So this will be 5 over 2 plus 5 root 3 I over 2. And then we get x6, the sixth value, 5 over 2 minus 5 root 3 I over 2. Thanks for watching. If you have found this solution helpful, please give this video a thumbs up. Subscribe to my channel if you have not done so already, and I'll see you in my next video.